Okay, good morning 10th class. Today our topic is extraction of moderately reactive metals. In earlier video we have learned about extraction of highly reactive metals. Okay, with the help of electrolytic reduction we get metal, those who are highly reactive like potassium, sodium, aluminium. Okay, now just see, today we will do extraction of moderately reactive metals. Moderately reactive metals means those who are not very highly reactive and not very less reactive, intermediate one, like zinc we have lead, manganese, iron. Okay, those who are intermediately reactive. Now in this one, first of all, concentrated ore, concentrated ore means, concentration of ore means that is removal of impurities by different method. So now in case of extraction of metal, moderately reactive metal, first of all, concentrated ore can be converted into, okay, oxide ore. Their oxide ore, with the help of that process, calcination and roasting. Okay, that one. And once it is converted into oxide ore, okay, after that, with the help of process reduction. Reduction means, okay, simple. It's either removal of oxygen, okay, and it's a addition of hydrogen, or either it's a gain of electron reduction process. Okay, so simple, it's a reduction process, so we can remove oxygen from that oxide, metal oxide, and then we get metal. Okay, now in this one, okay, not only calcination and roasting process for this, but for 10th class we have so many other processes also, okay, for extraction of these moderately reactive metal. But for 10th class we have two method, calcination and roasting. That one is more important, so we'll do that only. Okay, now in this one, okay, now in this one, the first process, again it's both are very important, calcination as well as roasting. The first process is calcination. Okay, that one is calcination. Generally calcination we use to convert carbonate ore into oxide ore in the absence of air, means no oxygen. Okay, so simple, the process of converting carbonate ore into their oxide ore in the absence of air, that process is known as calcination. Okay, then in this one we have one general example, that one is zinc carbonate. This one is zinc carbonate. Okay, now in the absence of air, which process occur? That one is calcination, and it is converted into zinc oxide plus CO2. You have to balance the equation. This equation is already balanced. Okay, this process is one process, that one is calcination. Okay, now this one is ore, that one is calamine ore. This one is calamine ore, zinc carbonate. Okay, this one is calcination. Now we have another process, that one is, okay, roasting. This one is simple process, that one is roasting. Now roasting, this process we can use for sulfide ores. Okay, for example, just see, if we can take ZNS, this one is zinc blend. Okay, this one is ore, sulfide ore of zinc blend. Now in case of this zinc blend, simple roasting is the process in which sulfide ore is converted into oxide ore in the presence of oxygen, and that process is known as roasting. Now just see, simple, ZNS in the presence of oxygen, then it is converted into ZNO, and this one is SO2. Okay, you have to balance equation also. Okay, now this one is Zn1, metal 1, sulfur 1, here also 1, but oxygen is 2 here, and here oxygen is, okay, 3. So we can balance it. Obviously this one is, just check, 2. You have to balance it. Here also it's a 2, but now sulfur is also 2. So now number of oxygen is 3. So this one is 3. So it's a 2, 3, 2, 2. This one is your balanced reaction. So this one is roasting. Both calcination and roasting is very important for your either for your exam point of view, for board exam. Okay, maybe their difference will come, maybe simple definition will come, and you have to write equation accordingly, but this portion is very important. Okay, now once this either it's a carbonate or sulfide, or they are converted into oxide, then simple will do reduction. Okay. Okay, now just see, once they are converted into metal oxide, so then reduction of metal oxide. And who help in reduction? Okay, simple reducing agent. You can take any reducing agent which help in reduction. Okay, carbon monoxide, carbon dioxide, they all are reducing agent. But we have other elements also, those who act as reducing agent. Now this one, ZnO plus carbon, this one is act as reducing agent. This one is reducing agent. Okay, now so this one is carbon, then it gives, okay, that one is zinc plus carbon monoxide. Okay, now another one is, this one is one thing. Now if it is manganese dioxide, this one is MnO2, so this one will not reduce with the help of carbon. For this we'll use more powerful reducing agent, and that one is aluminium. So aluminium, okay, so MnO2 plus aluminium, it acts as a reducing agent. And when we use aluminium, so we'll use aluminium in powdered form. Okay, and it is converted into manganese plus Al2O3. This reaction is balanced, plus heat is evolved. Okay, thank you.